Hello everyone, my name is John Krajewski and I am a member of the product management team here at Invences Wonderware. In today's video, I want to walk you through some introductory concepts on how to use proper design elements inside of your human-machine interface to achieve better situational awareness. Specifically, when I mean design elements, I'm going to be talking about the symbols and what symbols offer better or worse situational awareness for your operations. So I'm going to start here in this first example of talking about a flow transmitter. So traditional techniques for showing a flow transmitter would be that you would show the tag name. So here, FIT123. You would show the actual value. Here it's showing you it's 55 or in going down. And you see the units, in this case it's gallons per minute. And you'll see I've labeled these as perception. We talk about 3 levels of situational awareness, with the lowest and the poorest being perception. You understand that the value is 61 right now, but what does that mean? So moving from perception up to comprehension here, where now I have a meter showing this, I can see that the value, the number is still here. I can see the numeric value, but now as I'm seeing this graphic that's next to it, I'm able to comprehend what it means a little bit better. Meaning that here I can see that the green line is my set point. I'm currently slightly above set point, and I'm moving down. I can see this thing moving down, but I'm well within my alarm limits. I'm within the expected operating range as well. And so here I can see a little bit more, and I've gained more than just perception, but I've also gained now to comprehension, a little bit more of the meaning. Going to the third level, is what we're referring to here as projection, starts giving me an understanding of how can I expect this to behave in the future. A couple ways you can do that, but this one specifically, we're showing a trend. And this trend is showing you not just where you are in relation to that meter. The meter's still present that I was talking about during comprehension. But now with projection, now we're able to see, well, the rate at which I'm moving. Kind of I can look at the past and I can see how things are going to be acting in the future. So I can see that this has been wavering pretty far from outside those operational limits. It's not going into the alarm limits, but it's going pretty close to those. And so that overall I can get the impression that I'm not really controlling the signal too very well. So when I look at these questions here on the end, is it close to set point? Is it outside operational limits? Is it nearing an alarm limit? How well is it being controlled? Does the operator need to intervene? And what will happen if no action is taken? I'm able to answer these questions much better with this symbol here on the right, which is utilizing projection. I can sort of get many of these answers with comprehension, and really I can't get very much out of this first one, which is perception. And unfortunately, this perception technique is the one that most people utilize today, and why we saw a need to introduce methods and design elements to make this easier. So I'm now going to move on to my second example here, which is I've got three variables which are key indicators for a process. So I've got a flow, a level, and a turbidity. Turbidity is a measure of clarity of water. So this is a water filter, and I want to know how well am I doing. The first way of indicating it, just using numeric values, when the classic way of tag name, numeric value, and engineering units, don't really tell me how well I'm doing, because I'm only able to know exactly what the values are. When I use these meters here in the middle, I get a little bit better. I'm better because now I can see that my flow is right on set point, my level's on set point, my turbidity is still pretty low, so I'm doing pretty good here, and I can see that. But it requires me to take a little bit of time to read them individually. If I'm just trying to get to understand how well the process is performing, this polar star is a very effective way, and I've labeled it as best, but this is somewhat subjective by the individual as to whether the meters or the polar star is best. But one thing that can be said is it's really quickly able to assess that the blue line is where I am now, and the green line is kind of where optimal is. And I can see that my turbidity is actually a little bit lower than optimal, and in the case of turbidity of water, that's good. So I can see that my process is pretty good right now. So I can see, are the KPIs at expected values? How well is it being controlled? I'm doing a pretty good job. And does the operator need to intervene? And in this particular case, the answer is clearly no. But when you just look at these numbers, if you don't understand the context, you really don't know the answers to those questions. I'm going to look at this third example here where I've got 3 temperatures. So I've got temperature 1, 2, and 3. And I'm trying to understand how well are these being controlled individually. Again, the first one is kind of just showing the numeric style as is classically done. Again, I don't really know how well those are being controlled at present. These meters do a little bit better job, so now I can see here that the current temperature is within the operational limits of the system. I can see they're close to set point here, and they're starting to get too close for me to understand exactly how well one's doing over the other. When I use this chart here of the deviation chart, I can see much more clearly that temperature 1 is the one that's the furthest away, but they're all within 1 degree of their set point. So I'm probably doing quite well here. Here I just saw some noise got introduced in the system, and now I can clearly see temperature 2 is the worst performing of the 3. And so it's easy for me to identify that with this visual technique here. So now I'm going to be going on to the question of when I have a lot more than just 1, 2, or 3 values that I'm looking at. Now I've got a case here where I've got 20 different values I'm trying to understand. It's very difficult for the human mind to look at 20 numbers and make any sense of those 20 numbers at any point in time. So what I've done is I've used other techniques to be able to show different types of information. You should be okay to be able to show the same information in multiple ways in order to identify for the operations team the right information that they're trying to get out of it. So not that you always have to have multiple techniques, but sometimes that can be effective because not always the same technique can convey the same information. So here we're looking at trends of values. When I look at these bar charts, or these column charts rather here, I can see trends in those values, and I can see trends across the different values that are quite visually perceptible. They're not very easy to see when you're just looking at the numeric values, and it's hard, and especially when those numbers are moving, for you to be able to see these trends in real-time data. Here's one where I'm actually using a bar chart where it's automatically sorting and stacking it. Which one's the highest? So here I'm just looking at KPI 1 and I've sorted it largest to smallest. So I can see B1 is currently my highest and B10 is my lowest. But you'll see that these numbers will shift around as the values change. Now B2 is my highest. But it's always quickly able for me to see which numbers are my highest and which are the lowest using this visualization style. Here I'm actually showing how I can look at how do these things relate to each other. So if I'm trying to understand the difference between values KPI 1 and KPI 2 and look at them across the system, so what I've got is I've got this gain-loss chart where I can see where my gains are on the top and my losses are on the bottom, if you will, and this line is showing me the net result. So not that these individual techniques are going to be something that's applicable in all situations, but to state that if there is something that you want your operator to be aware of, if you provide a visual technique which makes it easy to assess that, then you'll be able to take an inexperienced operator and make him as effective as a very experienced operator, or even more effective than an experienced operator, by using some simple visualization techniques such as these as I'm showing here. So I'm going to now move on to the next one here, which is a common case where people use gauges. Gauges are kind of, these are computer representations of their physical analogs where people would use gauges, and these were, physical things that people were used to. Things that are somewhat poor about these, if you're just trying to look and compare them, it's kind of hard to compare and contrast against these two because they're not right next to each other. So it is somewhat difficult to compare and contrast with these gauges. The visual presentation style, while some people may find this pleasing in certain ways, can be somewhat distracting, as really the only thing that's being communicated by these gauges here on the left is the current value. So it's not a whole lot more valuable than just the numerics if you had them alone. When you look at these bullet graphs on the right-hand side, they're easily comparable because they're stacked right next to each other. They're basically showing the same information, so I can see, how far they are in a range of a 0 to 100, which was the same range shown by these gauges. I can see a bit more about qualitative information. Here, the dark areas are bad. The gray shaded areas in the center are satisfactory, and the green, the blue areas, the white areas at the top are the good area, and these lines are kind of the target. You can see that all of my values right now are well below their targets, and there's probably something I should be looking into here. But this communication of both the qualitative information around the good, bad, or satisfactory, as well as the quantitative numeric values and the distance from their expected, I can actually make a much more valuable discernment of what's happening inside this system by utilizing these bullet graphs on the right. And my last example that we're going to show here today, I'm showing multiple temperatures around a vessel. So I've got 10 temperatures that are around this vessel, and I'm trying to understand if there's anything that's deviating. And when you're showing here that around these numeric values require you to go and inspect each individual number and understand what they are in relationship to the others. It's a really slow and error-prone process by using that. In this parallel coordinates chart here, where each point is a different variable, and I've used a connector line to put them, I can basically see where any deviations are. Here in the bottom, and where I've labeled best, you can see I've got them all as meters, so I can know where they sit with regards to whether or not they're within expected ranges or not. I've connected them so I can see lines, because the human mind is very good and adept at being able to see changes in line direction. And I've also got information like alarm information, so I can see temperature 10 recently was an alarm, but it's back in normal state now. So this allows me to much more effectively communicate what's going on with these temperatures. This was just a few examples of some of the techniques that are possible with inside System Platform 2014 and InTouch 2014. With inside of that product, there are many more techniques that you can utilize and many more symbols that allow you these types of situation awareness design elements. And so keep your eyes open for more videos on this concept going forward. Thank you.